Okay, so our last speaker before lunch today is Stefan Slivinski from Lifesize. He's a principal engineer at Lifesize, a division of Logitech. Stefan spent the better part of his time at Lifesize running the video engineering team, which developed the video algorithms that went into all of the Lifesize hardware video conferencing endpoints and infrastructure. More recently, he has been leading the expansion of the Lifesize cloud service offering. Stefan, welcome.
Thank you very much for the introduction. I know I wrote the introduction, but it's better when someone else says it. So I want to do, I'm a distinguished engineer. I know I'm wearing a collared shirt and dress pants, so it's sort of my jeans and hooded fleece are at home. I wanted to kind of start off and talk about is the clicker up here? Okay. Real-time video services in the cloud. And so before I kind of get into that, it's good to look at other existing services in other industries where they've had sort of a very large transformation in terms of what they've been able to enable other people to do. And that's really the objective here, is to be an enabler for other solutions or other companies. So one of the obvious ones that most of you have certainly heard of is YouTube. And what they did that was particularly interesting was not, I mean, one of it was solving a problem back when they first launched was where to store videos. When you record videos of your family or your friends or something like that, and you want to be able to post it and share it with other people, it was very difficult at the time to actually do that. And so they solved that problem. That was a very, very difficult problem to actually host video files and actually provide the bandwidth at the time for millions of people to potentially view these files. But something else that they did that was also very, very interesting is they provided you the ability to embed those videos in your own website. And so this for a small website that might have a microblog site or something like that, to actually handle video and video bandwidth was just an impossibility. And even today, with the accessibility of bandwidth, it's still a challenging problem. So that was one of the big enablers that YouTube provided, and that service they provided. Another we look at is AWS, and Amazon is sort of a pioneer in this space with the cloud computing side of it. And they had a very interesting problem that they needed to solve. They had this very seasonal business where, right around Christmas time in the US, there was a huge influx of customers. And so there's obviously the logistical challenges of how do you actually ship all that stuff to all these people. But more importantly, it was how do you handle all of the traffic to all these servers at this one point in time when the rest of the year you really don't need that server capacity, not to that extent that you need it during Christmas. And so they thought, well, maybe other companies have similar problems. Maybe they have this sort of seasonality, or maybe even just during the day in North America you might need more servers than you need in Europe versus vice versa in the evening hours. So they all, how can we help other companies solve their problems, solve their sort of elasticity in terms of server capacity? So they offered this as a service and said, well, you as a company can have, kind of pick out the average rather than the peak of your server is required to host your business. And then during the sort of peak periods, you can just subscribe or spin up a server on Amazon, host it for days or hours or whatever you want, and then turn it off, and you just pay for what you used. And so it was a very sort of innovative technology. And now a lot of companies are like, well, I don't even want to run my own server. I don't care about, that's not my business, isn't running my server. I don't want to run a data center. So I'll use Amazon for everything. And there's a lot of very high profile companies, Netflix, NASA, a lot of different places that actually utilize Amazon exclusively for their hosting their websites. And the last one I wanted to mention was Twilio. This is not sort of the staple name that everyone has heard of, that like Amazon or YouTube, but they have a very unique service that has a lot of parallels to video communications. And what they offer is the ability to make voice calls through an API. And so this isn't just voice over IP to from PC to PC. What they really offer is the ability to actually call regular landlines or mobile phone numbers, so PSTN lines. And that was something that a service that Skype offered for since the beginning, I think, more or less. But for you to kind of reinvent the Skype today using Twilio as sort of a component, it's drastically simpler than it used to be. So they've really streamlined and made this whole process extremely simple. I mean, just the installation required, the infrastructure required to actually do what they do is fairly complex, and someone who isn't their core business doesn't want to invest in that. So they've removed that barrier of entry to actually calling telephone numbers. And so as an extension of that, they've added SMS capabilities, so you can do text messages and stuff. And you'll see this a lot now with this two-step verification systems, where they will send you a text message to your phone number with some ID that you need to enter on the website. It's a whole horribly painful experience, but it allows another way to authenticate who you actually are. So if you kind of take a step back and look at these different services, there's some sort of commonalities that come out there of what are the qualities that really make them great. Because a lot of them were not necessarily the original innovators, but they've certainly become sort of dominant in their markets. So if you kind of boil these down, they're fairly sort of obvious or common sense type things, but it helps to mention them. So I call these sort of the basic elements to a great service. And the first one is accessibility, and this is really for the developer. It's really around you want to get access to the API, you want to get access to the documentation, so you can start coding immediately. You can produce some sort of proof of concept very rapidly, and that's part of what these services are, is to accelerate that kind of development. And so having obstacles where you have to go and call a salesperson and say that explain your business, and this is I project that we're going to have this kind of market cap, and it's just like, I just want to try it out. I don't need to go and talk to somebody to do these things. So those are barriers to entry. So you want to remove those as much as possible. Generally, you don't want to have to call customer support. You don't want to ask a question, email somebody. But if you do, if there's situations where you have to, you want to have great customer support, so that you're getting a direct answer to your question and you're getting it quickly. So the next one is around simplicity, and this is really more pertains to the API itself. It's really, and I wrote here, target mediocre developers. That's not meant to be insulting to developers who are mediocre, but it's really, you don't expect them to be experts in your field. That's what you are. You're trying to abstract all of the complexity into this simple to use API. So video compression as a sort of relevant example. They shouldn't have to know what the quantizer is or what block matching algorithm they have to use or motion estimation. If you are providing facilities to control that, then you are missing the point. The objective here is to make this simple. They want to make a video call. They want to call an API that does that. They don't want to have to figure out, how to set up the codec correctly. So they don't even care about 264 or VP9 or VP, whatever, it doesn't matter. So the objective here is to make it simple. And then examples. I mean, especially with the web, with so many different languages of Perl and Python and JavaScript and I don't know, take your pick. But you want to provide examples. You want to provide a lot of examples in various languages, so that the developer you're targeting, or who is sort of an expert in that particular language, can go and look at examples that he understands. And so don't just provide it in C++ or in JavaScript or something. Provide additional examples. And the last one is reliability. And this is one of those ones that sort of gets ignored or not treated very seriously. And it's when you have a new sort of novel service, you kind of hope that alone will sort of prop it up and people will be more understanding. And that's true to a certain extent, but there comes a point where if they're trying to run a business that's based off of your service and it's not reliable, that hurts them a lot. I mean, at the end of the day, they're paying you money to provide a service. So the expectation is that service is going to work. So let's take a kind of turn it around and look at how this pertains to enabling real-time video services. And so I think the call center example was brought up earlier in Ori's talk, and this is a great one because it's such a horrible user experience today when you have to call a bank and you punch in a number and then you go through all these different various authentication steps and then you actually talk to a real person and then they re-ask you for all that information again. So it's a perfect opportunity to kind of reinvent something that is really set the bar extremely low. And so if you kind of break this down into sort of its core pieces, one of the main things and one of the most important things is to have something as ubiquitous as a telephone. And that's really around the client. You need an accessible client to actually make calls from. And so, for the PC, you need something for the PC, you need something for the smartphone, something for the tablet. Now, from the server side of things, there's some of the obvious things. You need some sort of call queue. So if you've got a bunch of people calling in, customers that are calling in, they need to be mapped to, physical representatives. Typically, you're going to have less or more customers and representatives, hopefully. And so that you may have different priority levels where you can say, well, maybe this customer is a VIP customer, and let's map them to someone that actually knows what they're doing, and then everyone else can go to the people that don't know, something like that. And then you want call recording. I mean, just for quality assurance purposes or training that you hear those messages. So you need some sort of mechanism to actually record the conversations that are going on. And then the last one is just sort of around call transfer. So you got the agent that they don't know the answer, they can transfer you to a different department, and so you want this sort of call handoff. So if we take these and we look at them in terms of building blocks, and so you kind of create these basic building block services. And so from the client side, what I mentioned before, you want PC, you want smartphone, you want tablet. Those are kind of the primary mediums today that you need access to for a client side. For the services, it's all kind of the same ideas. You want a service that has a call service, a queue service, streaming service, transcoding service, recording service, multi-way, and you can add a whole bunch of other ones. But they're all kind of these self-contained, independent services that are basic building blocks that can be used, interconnected to build something more a larger solution. They're kind of a part of a larger solution. So if we start with the client, we have for the PC, the WebRTC is an obvious one. It's if you're not familiar with what WebRTC is, maybe you shouldn't be here, but the WebRTC is really it's just simply a client. So that's all it's able to do. It's able to make video calls to some other client. Now, there's obviously problems with it, and like every technology, it's not perfect. It's lacking support from Internet Explorer and Safari. You have support with Firefox today and Chrome are kind of the main ones. I think Opera is also there. Those are kind of some of the challenges with it. And then there's just these browser incompatibilities. So Google doesn't want to do 264. We already heard about that this morning. And then you've got Internet Explorer and Safari are more than likely going to want to choose 264 and not do VP8 either. And then you got Firefox, who's kind of the Switzerland of the browser markets, and they'll do everything, and they're happy to someone will keep using them. And then you have, so these are challenges, but they're not insurmountable. So this is where the server can come in and act sort of as an intermediary or a translator. They can go and convert from 264 to VP8 or from VP8 to 264. It's a sort of a waste of resources if you have to do that for every single call leg, but it's an option. It's a possibility, and this again is likely a short-term problem. At some point, things will get sorted out, and we'll hopefully have a common language that we can all talk. Now, from the smartphone and tablet side of things, this is a bit more complicated. Certainly, you have browsers on your smartphone, and Chrome exists on Android smartphones, so that's a possibility. The form factor is kind of awkward. But then you've got the problem of iOS and Safari, and there's the lack of support there right now. So that's difficult to kind of manage at this point in time. The other option is apps. And typically these companies that are developing all these apps, whether it be banking or some other kind of market, they have the ability to, or they have existing apps today. So likely they're going to want to integrate this directly into their app rather than having you to go to some sort of website somewhere to do a call with their support team or with their customer service team. So, but the problem with that is that there's no WebRTC of apps yet. So that means some sort of heavyweight app, which is essentially just a software codec that can run and make video calls and handle decoding and encoding of video. So if we look at the service architecture itself, this is kind of where these are sort of the basic requirements for all services, and it's fairly simple in that each service in of itself needs to be self-contained. So you have a calling service that can do calling it by itself, or it can be combined with something else that will allow you to kind of do something more complicated. And so this is kind of the independent and or connected possibility, that the building blocks I talked about. And this philosophy of the whole is greater than the sum of its parts. And this is where I think an example will better kind of illustrate what I'm talking about with this. So if you take two types of services, a recording service and a streaming service. The recording service, if you think about YouTube again, YouTube right now, if you want to go and publish content, if you want to upload a video, you need to record a video, and whether that be on your computer or somewhere else, and then you actually go to YouTube and you need to upload that file. The other alternative is that YouTube could provide you a facility where you can record directly to the YouTube servers. And so that means pressing the record button, and then it would go and stream directly to YouTube, and then it would save it to YouTube servers, and they can do all the transcoding for you, and then the video file is immediately ready for viewing or to be published. And sort of the streaming side of this is that now you want to review that video and you want to see if you did it right, or you maybe want to try it again. So the streaming would then facilitate the ability to actually watch it again and then decide whether to publish it or not. Now, if you combine these two, then you can do something a lot more interesting. So now, while I'm recording to the YouTube server, I then press the streaming, or I enable the streaming service, and now I'm able to do a live broadcast. So whether it's a webcast or it's a live broadcast of any sort, it's a much more kind of more complex solution. So two small pieces put together can build something a lot more impressive. So the basic conclusions are the client is really the biggest barrier of entry to any of this stuff. WebRTC takes us a huge step in the right direction. It's not without its problem, but it's close. The smartphone and the tablet side is a bit more sort of murky in terms of lack of sort of a simple solution. The simplicity in the way that WebRTC is simple. And then the server side it's really around these kind of services, real-time services that are all very independent and modular, and then can be combined with other parts and enabled by other companies to build much more complex solutions. So that's it. Any questions? Everyone want to eat? Is that what? I'm hungry too. All right. Good. Thank you. Oh, sorry.
I don't know if you mentioned, I didn't say it. So on the cloud side, on the server side,
yep.
you in the Lifesize case, you use transcoding in the cloud. Is that correct?
Yeah.
Yeah. Okay.
Yeah. Yeah. So I mean, this is sort of the question was, in the Lifesize case, we do transcode in the cloud, and this is sort of a generic example. It could be whether you're actually doing transcoding or you're doing switching in the case of SVC or something like that. Conceptually, it's all the same. So the transcoding case helps with the 264 VP8 scenarios where you want to be able to translate those to clients that don't understand them, but certainly there are cases where it's not like the multi-way case. It doesn't have to be a fully transcoded multi-way. So.
Okay, any other questions? No? Then Stefan, thank you very much. And